Okay, I'm going to do the video on series circuits, and I just want to point out where your electricity equations are. They're section 9 over here under electricity. And right now I want you to pause the video, and besides Kirchhoff's current law, I want you to write parallel, and beside Kirchhoff's voltage law, I want you to write series. Because this is only good on parallel circuits, this is only good on series circuits. And you are going to be using these in the examples I'm going to be doing for you. Notice also here's the total resistance for series and the total resistance for parallel. These are the formulas I'm going to use when I work them out for you. Okay, so this is the example problem that you have for series circuits, and it first asks us to find the total resistance. That's the formula I just showed you. So I went ahead and copied it from the formula chart, which says R total equals R1 plus R2 plus dot, dot, dot. What that means is I just keep adding them up. If I have 2 here, I just add them. If I have 100 here, I add them all up. And our resistance is this right here, 220 ohms. Ohms is what we measure resistance in. 220 ohms, 470 ohms, and 1200 ohms. So you just take these, add them up straight on your calculator, and you get 1900 ohms. Then, because 1900, we know how easy it is to mess up these zeros. Electricians really like to change things over to either kilo or milli. So this we're going to change over by moving it 3 places over. We're going to change it over to kilo ohms. So this should be 1.9 kilo ohms. That was part 1, find the total resistance. Now part 2 says find the current flowing through each component. So we're going to start on this by finding the total current. And in all of these, we're going to use Ohm's law a lot. Everything in electricity, almost everything comes back to Ohm's law. So we're going to start with Ohm's law, which is V equals IR. And here we're going to do it with the totals. So I look at my problem over here. Do I know the total voltage? Yes, it's right there. Total voltage is 12 volts. I'm looking for the total current. In part 2, I'm looking for current. And I know the total resistance because we just found it here. So I'm going to put that in right here. And I do need to change it back to just use the regular ohms part. And I'm going to find the total current. Go ahead. Which one do you divide by? Basic algebra. Divide by the 1900 ohms. 12 divided by 1900, and we get the total current is 0.0063 amps. Or again, they don't like to do all these extra zeros when they're doing electrical engineering. So we're going to move it over 3 places and change it to milliamps, 6.3 milliamps. Now I need to find the current in here, here, and here. And when we're talking about a series circuit, make a little note here. Current is the same everywhere. In series, the current is the one that's the same everywhere in the circuit. So what that means is IT equals I1 equals I2 equals I3. Everywhere I measure it along here, the current is always 6.3 milliamps. They're all the same. Okay, now to find the voltage everywhere, I'm going to come over here. We're going to use Ohm's law 3 times to find the voltage at each one of these locations. I already know the total voltage because they told me right there. I'm going to write it down because they asked me to write it. VT equals 12 volts. And I'm going to then find it at each one of these locations. So I'm going to write the Ohm's law, V1 equals I1 times R1. So we're doing Ohm's law right here. Do I know the voltage right here? No, I'm looking for that. Do I know the current right here? Yes, because it's the same as the current everywhere else. So that's 6.3 milliamps, but I need to put in the regular amps there. And then my R1 is the 220 ohms. You need to always put in regular amps and regular ohms and regular volts in this equation, and then it works out properly. If you start putting the milli in, it will mess up your answer. So to find volts, I just multiply these two numbers together, and I get V1 equals 1.397 volts. Now we need to repeat the process for V2, so I'm going to do that. Okay, so I did Ohm's law for the second point right here. I plugged in the I2, which is the same thing here. I plugged in my resistance 2, which is that one right there. Plug this into my calculator, and I get 2.984 volts. I'm going to do the same thing for the third one. Pause and rewind if you need to get these down. So to find V3, we plugged in the current, same current that we had here, 1200 ohms. You have to use the 1200, not the kilo ohms, but the regular ohms. Multiply that on your calculator and you get this answer here. So that's what they ask us to do in part 3. We found VT, V1, V2, and V3. Now it says use the results to verify Kirchhoff's voltage law. Well, if you look at that on your formula sheet, Kirchhoff's voltage law says for series that I should be able to add up all the voltages and they should equal the total. So what I need to just do to do this is add these three together and see if I get 12 from that. I'm going to do that here on my calculator and write it down. Okay, so I wrote down Kirchhoff's voltage law from my formula chart, and then I added V1, V2, V3 here, and I add them with my calculator. And I think we actually are slightly off because of rounding, but we come very close to VT, which is what we started with here. So we have verified that we got these three right. Basically, using Kirchhoff's voltage law, that's a way you can check to make sure you got each of the voltages correct.